students, in this revision 6 we are going to see some questions based on assertion and reason. Here 4 options have been given to us. First, both assertion and reason are A and R are true, and R is correct explanation of A. Second, both A and R are true, but R is not the correct explanation of A. Third, A is true but R is false. And fourth, A is false but R is true. Question number 1. A. Magnetic field lines have both direction and magnitude. And the reason for that they have given us, the field lines emerge from the North Pole and merge at the South Pole. Though both the statements are correct, but this is not the correct explanation of A, so option 2 will be the correct one. Question number 2. A. Compass is a small magnet and gives direction of magnetic field lines. And the reason for that is, explanation, it gets deflected when brought near a bar magnet. Both the statements are correct, and this is the correct explanation of A. So for this, option 1 will be the correct one. Third, when two resistors of 4 ohm connected in parallel, total resistance is 2 ohm. R, when two resistances of 4 ohm are connected in series, total resistance is 8 ohm. Both the statements are correct, but R is not the correct explanation of A, so the second option will be the correct one for this. Question 4, for this, the angle of incidence and reflection are equal. And the reason for that is, the angle between incidence ray and normal is called angle of incidence. Actually, both the statements are correct, but R is not the correct explanation of A, so option 2 will be correct for this. Now question number 5. Identify the type of magnetic field represented by the magnetic field lines given below and name the type of conductors which can produce them. This one is the magnetic field pattern produced by a circular loop of conductor, and this one is a magnetic field produced by a current carrying straight solenoid. Actually, this is the uniform field inside a current carrying solenoid. The next question, what does divergence of magnetic field lines near the ends of a current carrying solenoid indicate? Now the answer will be, the divergence of magnetic field lines near the ends of a current carrying solenoid indicates the decrease in strength of magnetic field near the ends of a current carrying solenoid. Explain why a freely suspended magnet always points in the north-south direction. The answer for this is, a freely suspended magnet always points in the north-south direction because the opposite poles of magnets attract each other, and our earth itself behaves like a huge magnet. Next question, for the coil in the diagram below, when the switch is pressed, what is the polarity of end A? And which way will the compass point then? Here, when the switch is not pressed, at that time the compass needle is pointing in this direction. It is the north direction of this compass needle. That means the B end of this coil is the south pole and this is the north pole. So when we switch on or this switch, or then the polarity of this coil will be changed, and now the corner A will be the south pole and corner B will be the north pole, and then the compass needle will point in the opposite direction. Question number 9. In a straight wire A, current is flowing in the vertically downward direction, whereas in wire B, the current is flowing in the vertically upward direction. What is the direction of magnetic field in wire A and in wire B? We can see here, if it is flowing in the upward direction in wire B, then by using Maxwell's right hand thumb rule, we can see this is the direction of current and this is the direction of magnetic field which have been formed in the form of concentric circles around the wire. So this will be in the clockwise direction. And just opposite to that, in wire A, in which the current is flowing in the downward direction, now the direction of magnetic field will be in the anti-clockwise direction, which I have shown it here. Next question, an electron enters a magnetic field at right angles to it as shown in figure. What will be the direction of force acting on the electron? Now we know very well that the direction of current will be in the opposite direction of this electron. So if we use the Fleming's left hand rule, this will be the direction of current, this will be the it is the magnetic field, then the direction of force acting on the electron will be into the page. The direction of force will be into the page. Now the second part of this question, if instead of electron a neutron enters the field, what will be its direction of motion? Give reason for your answer. Now we must have to remember a neutron is a neutral particle. That means there is no charge, neither positive nor negative charge is there on it, so it will not be deflected, so it will move in the direction in which it has entered in the magnetic field.